Today will be a test, or well, Unit 1 assessment review. So I was going to explain some stuff about that as well as go over some of the problems on this practice assessment. So I sent out an email yesterday explaining at least some of the things you have to do. So there is this additional video that you have to watch on your own for quadratic functions and their graphs. It is what it is. It's an effort to catch up because of the hurricane. So that video is already posted on the lecture links tab in my math lab. If you have not watched that already, please do so. And that homework is due Tuesday and the quiz is due Wednesday. So with that homework, because it is so not necessarily too short notice, but since you're not there to ask me questions and everything, I'm having a review session at 12 o'clock today at 12 p.m. during my office hours. I sent out a link already. You're welcome to pop in there if you want, or you could just ignore it and figure it out on your own. It's up to you. But I'll just be doing problems from that homework or answering whatever questions you have. To explain the Unit 1 assessment right fast. So it's not technically considered a test. It is a test. It's an unproctored test. So unproctored meaning I won't hover over you. There's not going to be anyone hovering over you. So you take it on your own. You take this assessment on your own. You can take it anytime between this Wednesday at 6 a.m. and Friday at 6 p.m. You have, it's 13 questions, so it's nothing crazy. It's 13 questions and you have 70 minutes to complete it. So in essence, that's about a little over 5 minutes per question, if you like knowing all of that. I looked at the problems already. Some of them, you won't need that much time, so you can dedicate that time for other problems. I don't need any scratch work or anything. You just do this on your own. You do it completely on your own. You do it at your house, at your grandparents' house, at school. I don't care. You don't need any proctors or anything. However, if you run into tech issues, that's where the problem may lie. If you have any issues with your computer shutting down, your internet cutting out, then I'm just going to say that's unfortunate, and there's limited stuff I could do in that moment. So you have to make sure you take the test in a place where your internet's not going to give out on you for an hour, or your computer, make sure it's charged and everything works for a little over an hour. And if you had your accommodations sent to me already, you'll get time and a half. So instead of 70 minutes, it's 105 minutes. I do not think you'll need that much time, but it'll be there anyways. So that you will see this assessment pop up in my math lab. It's not, the link is not there yet. It will pop up on Wednesday at 6 a.m. So it's not there yet. It will pop up there and I will let you know. So Wednesday in class, we will not be talking about we will not be reviewing. We'll be moving on to the new stuff. Yeah.
Are we going to have a practice test that we got to take?
There is a practice test there's a practice test in my math lab, and that should be up already. Okay. You should be able to see it. In fact, that's actually a good question. Let me present my screen for those of you at home. So you will notice it says cumulative practice for Unit 1. That's actually what we're going to be going through today to review. But yeah, that'll be a good resource, as well as, unfortunately, I do have to assign more workbook pages, and this is when you need to have the workbook by now. If you haven't gotten the workbook, it's in the bookstore, the university bookstore, and you need to get that ASAP.
Yeah, they said they're running out too. So I just got mine last week. They said I'll run out quick.
Well, I guess we'll see what happens in terms of the
I mean,
quantity.
that's what she told me when I checked out.
Yeah, I'm not too sure what the logistics are in terms of counting the number of students and then ordering the number of workbooks, but maybe it's harder than I think to count and then order appropriately. Might be me. But in any case, yeah, doing the workbook pages, which will be due this Friday, I'm trying to assign the minimum number possible. I know they're probably not the most fun in the world, and you know, I'd rather do something else on my weekend than grade them. But I will go over the problems. I'll send out an email after class today and just explain the problems. I'll try to assign like 1 or 2 for each page. But yeah, doing the workbook pages will also be review for the test as well. So, let's see, workbook, assessment, we'll do the practice assessment in a second. The course notes, I updated them for this Thursday. So the notes, if you look at the end of the course notes, in fact, let me just show you. I updated them to have what we're going to be covering on Thursday. So you will notice a new chapter. So we'll be covering this on Thursday. And I'll have them updated with the rest of the notes up to the midterm over the weekend. I'm pretty much done typing them, but I gotta go through, check stuff one last time. So the notes are updated for this Thursday, and then after that, I'll update them for the whole midterm, up to the midterm. So, okay, so technology issues, hopefully you figure that out. Can other people see my screen just fine? So can you see, hopefully see my course notes and me scrolling around? I know you all in class can. Okay, so hopefully you figure that out. Other than that, all right, I explained the assessment. I explained, well, we'll be doing the practice test soon. And workbook pages, I'll assign them after class. Anything else before we get started? Any questions about anything? If not, again, video, you got to watch that. Review session will be later today at noon. And let me go ahead and stop blabbing and let's go ahead and practice for this assessment. So when you're going through this assessment, it's not as if one time you go through it will give you the full theme of problems that you will experience. If you take the practice test more than once, you might get some other types of problems that you didn't see in the first unit test. So it's not like that there's many, but I want to give you a heads up that you may get different types of problems when you go through these practice tests. So this one has 23, but if you start up another practice test, you might get some other ones. You might see some overlap, but you might not. I just wanted to give you a heads up. So we'll start off simple. Is this equation define y as a function of x? The answer is no. The answer is no. I gave you this one in class. I told you that this is because y has a square on it. So that's it. So I gave you that one. All right, cool. So that one's pretty straightforward. Also, I got the new monitor, so I'm very happy. I actually have a good stylus and good setup now. Okay, so even, odd, or neither problem. I think this is a fair problem that could be on there. It's determine, well, if a function is even, odd, or neither based off of using the criteria we talked about, or the pattern that some of you may have determined. So for even, odd, or neither, some people can figure this out by looking at the exponents. That's a good pattern to utilize if you're just completely unsure of how to go about this problem. All the exponents are odd. That's a pretty good indication that this would be odd. But let's say you didn't know that. You wanted to do this. You wanted to do this problem algebraically. What I said in class was we would start with even, checking for even. And this is when you turned every x value into a negative x value. And so you might notice that for this first negative over here, since this negative is being raised to the third power, it will stay ultimately, not get canceled out, which means that negative gets to move to the front to join that negative, which would cancel out and give you 9x to the third. And somewhat similarly, the negative over here would come out to join the 8. Which would give us 9x cubed, 9x to the third power, minus 8x. The question is, does that give us the original function? No. It is not the original function, because naturally the signs are off. So it's not even. For odd, we take the immediate result that we got in the even step. We just put a negative sign in front of it. And try again. Naturally, the negative sign distributes. We just get negative 9x cubed plus 8x, which does match the original function. So it's odd. So that's two ways of determining it. You can either do the safe way of doing it algebraically, or you can use the patternized way, which normally I don't suggest patterns, because as you know, my math lab, there's tricky stuff at you. And tricky stuff, what makes it tricky? It doesn't adhere to a pattern. But this might be one of the safer patterns, just in general. So use at your own risk to look at the exponents. Is anyone in class, people? Do you have any questions about this? Virtual people. Okay, so that should start off pretty straightforward so far. Okay. I wanted to, so I don't want to do this problem. So if you started writing it, I'm going to change it slightly because there's a problem in the homework that I kind of want to resemble instead. So instead of parallel, I want to look at perpendicular. So, okay. Instead of parallel, perpendicular. Instead of y is equal to 2x, I'll make y is equal to 1/2 x plus 5. And it'll contain the point, say, 2, 1. Because in the notes, I did not do a problem of this degree. So I'm just changing the problem to something a little bit more helpful. So perpendicular to a line, y is equal to 1/2 x plus 5, and it crosses through the point 2, 1. Now, whenever you see perpendicular, it means take the negative reciprocal of original slope. So naturally, you want to figure out what the original slope is of the line that is given. So naturally, it's pretty easy to determine the original slope because that line is in mx plus b form, which means it's really easy to determine the slope in the y-intercept. It's just 1/2. I mean, you could just look at it. And from here, we're taking the negative reciprocal of this. So I'll draw this arrow. We'll go ahead and take the negative reciprocal. Now, what does reciprocal mean? Flip. That's what reciprocal means, flip. So 1/2, you flip it, it just becomes 2/1, which is 2. So 1/2, you flip it, it's just 2, and then you apply, or you change the sign in front. Oh, 1 second, let me just write that again. So this would just be -2, in other words. So you change the sign as well. If it's positive, make it negative. If it's negative, make it positive. And from here, you know the slope of the new line. Or a slope of the perpendicular line. So you already have half of the answer now. And finally, what we have to do, well, there's 2 line formulas. There's the slope-intercept formula, and there's the point-slope formula. Well, we have a slope, which is okay in both cases, but do we have a y-intercept or a point? The answer is, we have a point. That's why they gave us this pesky point back here. So we have the slope, we have a point, you can use the point-slope formula. So we did that, which this is y minus y1 is equal to m times x minus x1. Just as a reminder, that's the formula. I'll go ahead and fill in the values. So notice I'm getting those values from here. So up top, where the point is given, that's where I'm getting x1 and y1, and I'm plugging those in exactly. We have to put the final answer in slope-intercept form. It also says general form, but I did not talk about general form. Frankly, you don't want to, it would be more work. You want to go read it on your own, I'll let you, but we'll focus on slope-intercept form. So we will need to distribute here. And then finally, we add one on both sides. This would be the perpendicular line, the formula of the perpendicular line. Besides, we already did the original, the problem I replaced, we did that one in that exact problem in class. Just that one we had a diagram. It was the same problem, just about. Does anyone class have a question? Go turn my attention to the virtual people. So do we simplify it? So simplify in the sense of, combining like terms. Yes, definitely. So my math lab, as you all have definitely figured out by now, is very picky about simplification. If you have like terms and you try to put an answer in where like terms are still prevalent, chances are my math lab will not like it. If there is a fraction anywhere that is not reduced, my math lab will probably not accept it. So if there is some sort of obvious simplification, you definitely need to do that. I guess it's all relative to case-by-case scenario as far as what the simplification entails. So let's go ahead. So if you're still writing this, then you'll have to watch the video or start getting used to taking screenshots of your computer. Let's go ahead and move on. And this one should be pretty quick. Plot some points, find the slope. Okay, so you've probably all started getting used to this little box that comes up. One thing to notice about the box is whenever you go to plot a point, in the top right, it does tell you where the point is at. There's some people don't notice that, but at that top point where I circled with my with the pen, it does tell you where the point's at. It happens all the time that people will just be off by one little space. Even though you know how to do it, you just click it incorrectly in my math lab, and then the whole problem would be counted wrong. So I'm trying to emphasize, if you want to make sure it's placed in the right spot to avoid all the nitpick of my math lab, it does say where the point's at in the top right. So I plotted 1, 4, 5, 3, and it does match in the top right. So again, simple process, kind of a pain of a software at times, just making sure you avoid pitfalls other students did. And since we have the graph, we could figure out the slope fairly quickly. I mean, since we have a graph, we could just use rise over run, where the rise is simply 1 unit. And the run, we just count it 1, 2, 3, 4. -1, +4. So the slope would just be, well, -1/4. That's it. Just count it. You can also use the y2 minus y1 divided by x2 minus x1 formula. That's generally if you don't have a graph, but we do, so this is a little easier. Does anyone have any questions? It's just pretty straightforward. Okay, here's a more interesting problem. So this is one of those transformation type problems, which really could be a problem from either the graphing with transformations section or from the quadratic functions in their graph section. Once you do start or have already started that corresponding assignment, let's see what happens when we interact with the graph, what it wants from us. So it does want, so we can kind of preface that this wants the vertical stretch or compression, the vertical shift, horizontal shift, and any reflections. So we're going to go through those one by one. So, and I'll do this in a different color for each one just to emphasize what is where. So this is the vertical stretch or compression. And this comes from numbers that multiply the function. Well, I think there's only one clear case of a number that multiplies a function or multiplies the function. That's this 2. So naturally, that would be the stretch or compression. In fact, you don't even have to tell which one it is. Now it is a stretch, but again, as long as you put 2 in for the vertical stretch compression part, it'll do it for you. And then there's also the next part you will see in that box is vertical shift. So vertical shift. So this is, if you forget, if you move the slider in my math lab, you'll see the graph go up and down. So in other words, this is telling you how much up or down you go if you forget vertical versus horizontal. And so since this is up or down, this is when a number is added to the function verbatim, or and on the outside. So that +3, that's being added to the function. That means this would be a vertical shift. And again, when you go up or down, this is a verbatim operation, which means if you add 3, you will go up 3. There's no opposite here. It's just +3. Let's see. I'll use a different color to represent horizontal shift. So for the horizontal shift, this is when you add or subtract to the variable directly. And naturally, that's going to be the +4, the x + 4. Well, that 4 gives us an idea about left or right direction. Since we are adding 4, then this is an opposite operation. We're going to go to the left 4. So that's why the horizontal shift will be -4. It's the opposite. So you will need to know this for the test. And that's all the ones here in this problem. And once you put all of those in, like, we can go ahead and see what happens. We can see what happens. We click on this, the box comes up, and we can go ahead and fill in all of these one by one. 2, it's a little skinnier, vertical shift of 3, horizontal shift of -4. We get a graph that looks like this. I'm going to emphasize this now because it'll help out later. The vertex is the point, and we can determine that pretty quickly. It's -4, -4, 3. So finally, we just need to figure out the domain and the range. And we have the graph, so that helps us. Now, the difference between my notes and the graph is that I use arrows and their graphs do not. They just sort of continue off until you can't really see them anymore. The domain here, in fact, I will just fill in the arrows. So for the domain, they do go to the left. So to the left and to the right forever. It's all real numbers, -infinity to +infinity. And the range, I will use a different color for this one. So the range is lowest to highest and y values. So the lowest point is what I just shaded in blue, and the y value for that is 3. So if anything, we know we start the range at 3, and we will include 3. So there's a bracket there. We will include that 3. And then the highest point is +infinity because it just goes up forever. So that would be how to answer one of these transformation-based problems. And there's nothing really computational about it. It's just identification, which means if you identify everything correctly, everything will work out fine. If you don't, then the opposite. So you have to be very careful about your identification. And it's one little thing you may label incorrectly, and it could cost you the problem. So does anyone have any questions about this before I move on? In-class people? Virtual people? If not, then let's go ahead and continue. Okay, so it's asking, does this quadratic function have a maximum or a minimum? This goes off of that video lecture that you have to watch on your own. So I'm going to speak on contingent upon the fact that I'm going to assume all of you have watched the video. These problems, or at least the max and min problems, are not too bad though. So if you're familiar with what a vertex is, the vertex formula, if you see, so my rule of thumb, if you're taking the test and it's asking for the maximum or minimum of a quadratic, you're going to be using the vertex. So it's a good rule of thumb. So quadratic function, max or min, implies it's the vertex somewhere. Because you may notice for the first part, it just asks, does this quadratic have a maximum or a minimum? So with this quadratic, this quadratic has a shape to it. So a standard quadratic it either looks like this or like this. It's a cup shape. It's either facing upwards or downwards. How do we determine which one is which? Well, in that video I explain it's the leading number. It's the sign of the leading number. So again, I'm going to assume that you've all seen that video. So the sign of the leading number, so the leading number is +3, which I just underlined in blue. That number is positive, so that's why positive corresponds to an upward shaping cup. So why did I mention any of this? We still don't know whether the function has a max or a min. Hold on a second. So with this cup shape, it naturally has a bottom value. Not a top value because it goes up forever, but it does have an absolute lowest value. In fact, to really emphasize that, I'll just draw it. It's got a minimum. So naturally, this function has a minimum value. So that's why the shape of the parabola or the cup matters. If it faces upwards, we will have a minimum. If it faces, well, upside down, if it faces downwards, it will have a maximum. And the only criteria is the sign of the leading number. That's it. Again, I explained that in the video, but there's kind of another explanation of it. And then it goes on to say, what is the minimum or maximum value? So what that is looking for it's not looking for the location of the minimum or the maximum. Oops. It's not looking for the location. It's looking for the value, which is a y value. Find the y value of the vertex. So in order to find the y value of the vertex, I explained in that video, we have to start off by finding the x value of the vertex. And in the video, I do call it v with a little x next to it, just means the x value of the vertex. So I don't have to write out x value of vertex every time. And so it's got one little formula to it. Negative b over 2a. Just got one little formula to it. And again, as I explained in that video, if you are familiar with the quadratic formula uses a's, b's, and c's. These a's, b's, and c's also come from the same set of numbers. So here, a is 3, b is 6, and c is -9. And it comes from the numbers in order. But we don't even need c because the formula just doesn't have it. So that will be -6 divided by 2 times 3, which is -6 divided by 6, which is -1. So I just plugged in a and b into the formula appropriately. I got -1 for the x value. But we're not done. have to plug that -1 back into the function to figure out the y value, and then we will be done. So to figure out the y coordinate of the vertex, we will plug in that x coordinate back in. Oops, not put x, put -1. So the value we just found before, now we're plugging that back into the function to find the y value. So let's see, so that's going to be 3 plus, well, really -6 minus 9, so -12. And that would be the answer. And this is a process that you should be familiar with if you're finding the minimum or maximum of a quadratic, which again is something I explain in more detail in that video. So there will be quite a few problems like this on the homework due Tuesday. Does anyone have any questions up to this point?
So the answer for the minimum and maximum is just the y value, sir?
Anybody? Because if not, let's move on to the next one. So I'm not going to do most of these parts because there's way too many. There's only a few I want to look at. Pretty much F, G, and H, the ones that people have struggled on a little bit. We did one in class like this. I wanted to emphasize how. So for part F, it's wanting to know when the function is greater than 0. So when the function is greater than 0, it's wanting to know for what x values is y here above the x-axis. And notice I'm putting open circles at each one of the places where the graph intersects the x-axis, because we're looking for when the function is strictly greater than 0. Strictly greater than, not equal to. So I'll put open circles at each one of those points that just remind us not to include those. So naturally, we have two different segments. So there's that hill shape on the far right, and then there's that kind of slither on the far left. So for each one of those intervals, we are going to use the x values to represent them, and we'll put in a compound inequality. So from over here, we need the x values of each one of those boundary points, each one of those ends. So the x values, so it looks like this one on the far left is -18. It's not -21. It's -18. And then the next one is -3. It's not zero. This graph is just a little bit of a pain. So if anything, we can start off by typing that in. Negative 18, this is a compound inequality. We put just a less than sign because there's an open circle. We're going to use a comma because we don't use unions with compound inequalities, definitely not. So that just denotes the first part, the hill right there. For the next part, which was all the way over here, the x value is 12 for the far left part, and the right one is 18. The only difference with this segment is that the 18 does not have an open circle next to it, which means we include it. That's why the 18 is included. I had a few questions about this, so that's why I'm emphasizing it here. That's why the 18 is included when all the other ones were excluded, when they were not involved with the compound inequality. They don't ask for compound inequalities too much, but this is one problem they will. So I suppose I'll check if anyone has any questions, and if not, we'll go ahead and look at the domain. So I'm going to erase all this, so if you don't have this graph, hurry up and get it. Okay, so we'll just look at the domain as well, because the range is very similar. The domain is furthest to the left versus furthest to the right, and it uses the x values. On this graph, the furthest to the left that we can go is right here. What is the x value of that? It's negative 21. All right, we go back to the graph and go the furthest to the right that we can go. What's the x value of that? It's 18. Are those points included? Yes, they are. So that's why, and this is still a compound inequality. That's why we would get the domain as negative 21 to 18, both of them included. And using similar logic, you would get for y. Notice I'm using a y instead of an x because range deals with y. I guess I'll just do this one right fast. The lowest point seems to be these two. And the y value of both of those is negative 2. So that's why I have a negative 2 starting this off. The highest value is a 3, which is why I have a 3 at the end. And they are both included, which is why I have equal to components as well. Those were the three main ones I wanted to talk about. Those are the ones that students have the most issue with. So, does anyone have any questions about this one before I move on? If not, let's go ahead and look at more problems. I'll come back to this one if we have time. I think this one's a better one to look at. So this is another one of those problems off of the quadratic functions in their graph section. Again, the video you have to watch on your own and do the homework for. So I'll go through this one. And the first question is, how do they want us to give the answer? So notice this one's different. Notice what happens for this one is you plot a point, but that box doesn't show up. So it's no longer a box. It's, all right, you gave the vertex, now give us any other point, and we'll give you the graph. So it could be difficult or it could be easy to do this. So let's kind of determine this. So I emphasize this in my video that there is two ways of putting these graphs in. Sometimes that nice box shows up and you can put in vertical and the shifting and the reflections, or sometimes you will have to put in 2 points, the vertex followed by any other point. So let's kind of go through that process. Now that we know what we're looking for, so if you haven't watched the video, then pretty much the main theme I repeat through the whole video is that you need to find the vertex. So you need to find the vertex. So I repeat that theme throughout the whole video. I'm going to go ahead and identify A, B, and C. Remember, they're the numbers in order. A is 1, B is 4, and C is -5. You can just see that from the quadratic function they give us. It's the numbers in front, where 1 is the understood value in front of x squared. So with the vertex, it's still the same formula, -b over 2a. So that's why I wrote out A and B and technically C, but we don't need C. B is 4, so -4 divided by 2 times A, which is 1. And so that is simply -2. Let me write it up here. I'm going to erase this. Okay, so that's the x coordinate of the vertex. So remember that V with the little x next to it, that just means x coordinate of the vertex. So the y coordinate of the vertex, you plug the x coordinate back in to the function and solve for y. So I'm just plugging in -2 into every x for the original function. And let's see, -9, is that it? +4 minus 8 is -4 minus 5 is -9. So you can throw all that in the calculator as well. You should get -9. So now we have the vertex. So here at the very bottom of the screen, I'm putting the vertex. It is a point. The vertex is a point. It just means it's not where the parabola starts. It's what does start and stop mean? It's pretty much the central point where the parabola will expand from or grow from. We'll see that a little bit more vividly once we have the graph. But if anything, we now have the first point that we can plot. The issue is, as we noticed with the graph, Caitlin, can you see? Okay. So what we noticed is we need a second point. We don't have that box, but we need a second point. Any point will work. How do we find a second point? Normally what I do is I find the y-intercept. That's a very easy point to find. So hopefully by now you remember how to find the y-intercept. So for the second point, we'll find the y-intercept. This is where you set x equal to 0. That's why this one's easy, because all the x's become zeros. And you just get -5. So when you plug in 0 for x, you get -5 for y. And as such, now we have 2 points. So -2, -9, and then 0, -5. Again, since these grid lines kind of merge together really compactly, in the top right, you will notice that it tells you what point you're at to make sure that you plot the correct point. Because you may attempt to go plot the correct point and you end up moving your cursor slightly, and it will ruin everything. Notice in the top right, I'll make sure it says -2, -9, which it does, so click. Then I'll make sure it says 0, -5, which you just look up here. So 0, -5. So just trying to tell you to avoid the pitfalls of past students. So that would be the shape. And as I did for a previous problem, I'm going to emphasize the vertex, as we will see momentarily why. Now they ask us to find the domain, the range, increasing and decreasing. The domain is how far to the left we can go versus how far to the right we can go. We get arrows on both sides. And as I explained in the video, for quadratic functions, you will always get, for the domain, all real numbers. And if you're curious, \INF will just give you the symbol for free, INF, just in case you're curious. And then the range, it's lowest to highest, and it's y values. So we'll color this in blue for the lowest value, which corresponds to -9. The highest value, we get positive infinity because of the arrows that just go up forever. These are types of problems that you will see. This will be a good majority of the problems that you see on that homework that is due tomorrow. So this exact process right here, maybe a few things added or taken out at a time. I mean, we're not done. We have 2 more things we have to find. If anything, I'm going to erase the work for the second point. So I'm just going to erase the second point scratch work. And we're going to look at increasing and decreasing. And then we will be done with this problem. So increasing, you can think about it as a roller coaster. So in which way would you be gaining altitude? Would you be going higher and higher and higher? And let's see, I can do that in, what's a good color?
Green.
Well, no, I said a good color. I'll pick green. All right, I'll do it in green. So increasing, so I'll do increasing and this nasty lime green color. Is that lime green? I'm not very good with colors. Okay, cool. So this greenish color. So increasing seems to start here, and increasing is when you go upwards. And so whenever you're taking care of increasing or decreasing, you use X values and no brackets. X values, no brackets. I noticed a few people did that on the homework or the workbook pages. So X for increasing and decreasing, this is always true. You use the X values, treat it as if it were a domain problem. But you never use brackets, ever. If you use brackets, I promise you it will be wrong every time. So for that green part I just highlighted, what is the X value of the leftmost part of that? The X value seems to be -2. So if anything, I know how to start this. I said never use brackets, so I will use a parenthesis. For increasing and decreasing, you could just throw in parentheses at the beginning. So I said -2 for that leftmost part. And for the rightmost part, we hit an arrow. So it's positive infinity. For decreasing, it is very similar. I guess I'll use orange. So for decreasing, all the way from here down to this point. And so this will be -infinity to -2 with a parenthesis, always parentheses. And that concludes this problem. So this will be the majority of questions for the homework that is due tomorrow. They will ask pretty much these same things. Graph the quadratic, given 2 points, find the domain range increasing and decreasing. And notice how the vertex comes into play at every aspect of that, except for the domain. But knowing the vertex helps you find all the other characteristics, because -9 and -2 are both coordinates from the vertex. Does anyone have any questions about this before I move on? If not, my video goes into this in more detail with a decent bit of examples. If not, then let's keep going. So hopefully everyone's copied everything. If not, please refer to the video. Before you start writing this down, since we have 10 minutes left, I want to make sure I do good problems. I think this is one I can knock out fairly quickly. So this is a problem I've actually referenced already it just doesn't seem all too clear why, perhaps. So something about a marginal cost. I don't know, that sounds a little complicated. 50th, something. And if anything, what I want you to notice is this quadratic equation. X squared minus 120x plus 8,800. I think we can all agree that's a quadratic. And then notice what it says afterwards. Minimize and minimum. Didn't I mention something about this? If you're given a quadratic, it says maximize or maximum or minimum, stuff like that. I gave an interesting rule of thumb for that. So just find the vertex. The vertex is going to come up in some way. So the vertex. So if we're finding the vertex, well, we have to figure out, are we finding the x coordinate of the vertex or the y coordinate of the vertex? In this problem, both A and B ask for some sort of minimum type characteristic. So it turns out part A wants us to find the x coordinate of the vertex. That is part A. And so the x coordinate of the vertex, as mentioned before, is negative b over 2a. I'll go ahead and write down what A, B, and C are from the quadratic here. A is 1, B is negative 120, C is 8,800. So if we plug everything in, we will just get 60. Because it's minus negative 120, so don't forget that. It's minus negative 120 divided by 2 times 1. So here the 8,800 doesn't even come into play. And then it wants us to find the minimum marginal cost. So for part B, naturally, wants us to find the y coordinate of the vertex. Which means we plug in the x coordinate. There it is. And so this is calculator work. $5,200. So A was 60, B is 5,200. And that's it. So don't let this type of word problem throw you off. Minimize, maximize, minimum, maximum, vertex. Don't let that complicate you. Does anyone have any questions about this one? Not. See if we can find one or two more. probably have time for one more. See if we can find one. Definitely know your parent functions for the test. So I put all the parent functions or library of functions on one page. So just make sure you have that quickly accessible. So that would be all of these. So you would just drag, cube root would be that one. And then you go on with the rest of them. Know your library of functions. Be sure you know how to do transformation type problems where they just tell you shift down 1 or go to the left 2 or go do a combination of these things. So make sure you can do problems like that. Okay, I don't know. So this would just be x squared minus 1. Shift down 1. We did this one in class. I do this one on the video. So as far as what I was saying before, you have to check the video, or you can ask me after class. So let's see. And I guess a good one to end up on would be the domain of a function. I think this is a good one to end on. So the domain of this function, well, the problem with fractions is that dividing by 0 is bad. So that means when the denominator is 0, that's bad. So what we want is when the denominator is not 0. Because when it is 0, we're dividing by 0. And that's bad. So naturally, we can solve for x. Oops, that's not true. Naturally, we can solve for x and figure out what x values would make a bad situation. I'll rewrite this because the next step I'm going to apply will be the square root. Because the square root and the square cancel out. We do have to apply a plus or minus. And now x is by itself. And we get plus or minus 1. But, of course, take it a step further with interval notation. So the two values that we are excluding are -1 and 1, which means naturally everything else is fair. So for each one of those intervals that I highlighted in red, it will get its own interval notation. We would get this as an answer. Since I am out of time, that is all I have concerning the Unit 1 assessment. If you have questions about this or anything else, I'll answer questions for a little bit until my next class comes in. So if you don't have any questions, you're good to go. Otherwise, Go ahead and ask away.
I'm gonna show you something. On Pearson, I hate Pearson, just throwing it out there. It says that this was wrong. I took a picture of it, because I was like, no. Because that was what they said, because it's shifting down 4 units.
Oh,
So
I've seen this question
it's
so
supposed
many
to be
times.
negative.
I've seen this question so many times.
Why?
Um,
I mean, was I wrong? It shifted down.
Well, yeah, you're wrong.
Well, I mean, I
here's
got
the
it
here's
right
the here's the
now.
thing. This is why you're wrong. And I don't mean to sound like
Is
you
it
know,
because it's
some-
reflected about the axis?
Yeah, so think about it. You go down 4. Okay, now you're here.
Well, but it says down first, though. The down is at the beginning of it.
Well, yeah, that's the point. You go down 4. All right, here, look at me.
Okay.
So you go down 4. The x-axis is here. Now you're reflecting about it. Up 4.
Okay.
That means
That's what I kind of thought it was, but I was like,
what you're doing is you're putting a
negative
negative sign in front of the whole function, which means the negative distributes.
Yeah.
And that's why what would originally be down 4, when you distribute the negative, it would be minus a negative, which is positive.
Okay. I mean, I kind of thought that was
It's a
reasonable.
very common.
But I wanted to ask you if, like, it was a mess up. I figured.
Oh, no, it's hard to find. I've only seen one in 10 years. Did you get your stuff figured out?
Yeah, I'm about to go just to the office right now.
All right, cool.
If they send it to you, can I make up that, that little, what was, I don't remember the unit that was.
Yeah, so you have to get that done.
Yeah,
I'd have to
before-
get that before Wednesday
Okay.
at 6 a.m.
Okay, I'm gonna go talk to them right now to see.
As soon as I get it, because once the assessment starts, I can't push assignments back past it.
I
So
got
if you get it to me before Wednesday at 6 a.m. when everything opens up, then I can push
All right.
push it back.
All right, man, thank you.
I zoned out for a little bit while we were talking. So, did you actually assign workbook pages, or are you like?
I was going to